Hello and welcome to another video. So we've got this Wem, you remember the Wem, the PA40 that was write off because it was just an uneconomical repair. So we're going to recycle this chassis and build an amp into it. And this is a bit more fun, doing day-to-day repairs. This is what I really enjoy, is building amplifiers projects. So we need to look at really what tubes we're going to be using for this first of all. This is a strange one. Let's just see. Anyway, the tubes we're going to be using, the output tubes, are PCL83. This amp's going to be two of those in push-pull. And here is one of the transformers we're going to try and use. So there's a good reason why I've chose these PCL83s. And let me just... Oh, the phone's ringing. Hello.
Oh, hi. It's Susan calling on behalf of Bright Life Cover. And
go away, Susan. We're busy. I get thousands of those, I tell you. It's just ongoing all day. So, after being rudely interrupted by Susan, we'll carry on. 120, 120, obviously wired. You can see that's wired in series there for 240. And there's a little 250 milliamp fuse across there. Really interesting. But a good idea to have on. So we're going to try and use this transformer. There is what I may find with this transformer is that I'm going to have too much HT voltage. As you can see there, this delivers 240 in and 240 out. The reason I chose these PCL83s is because the heater voltage on this transformer is 12.6, and if we look at the heater voltage, filament voltage is 12.6, which means that I can use these in conjunction with 12X7, 12AT7, AU7 or whatever, and they are 12.6. So the only problem that I can foresee with this, using this transformer with these tubes, is if we look, if we just hone this in a bit more, you can see that the let me get a pointer. Where my pointer's gone? Oh, it's there, look, there it is, protruding near the variac, protruding out of the variac underneath it. So you can see 250 max on the plates. Now we can push that plate a bit. These tubes are cheap and plentiful. No one uses them for anything else. They were used in televisions, which is seems to be a running thread with me, using television tubes for amplifiers. So we can put, I think we can push that plate voltage. The screen's 250, but we can reduce that. It's no problem. The power out max is 5.4 watts that you can see there. So we're going to have two of these in push pull, which that amounts to near enough 11 watts, but we won't get that out of it, of course. We'll probably get about 7 watts out of this amp, I would have thought, but it'll be great for recording. The idea, it's a low wattage amp, we can crank it up. Big amps just aren't popular nowadays. So that's the only problem I can foresee with this project, and I'll show you what I mean. So this is 240, 240, and the maths for the DC rectified and smooth voltage is times 1.4. So in other words, 240 volts, you see that on there, times 1.4, I think it's 1.414, but we're splitting hairs anyway there, times 1.4, that gives me 336 volts. Now obviously that will draw down when the tubes begin to draw current. The preamp tubes as well as the output tubes, that's going to draw down. So the question is, how much does that draw down? Now if that draws down to somewhere around 280 volts, we're only going to be shoving 30 volts extra onto that plate. We can reduce the screen voltage, but what we could do is put a sag resistor in the power supply just to bring that voltage down, something like 180 ohms, which was suggested on another project by a guy that subscribes to the channel, and I thank him for that, because I get some great information from some of the subscribers, great ideas. So that's one to try. So that's what we're going to do. Now we will need an output transformer for this amplifier, and that's another problem. So most of the transformers that I've got, the effective load resistance won't be correct, and even if we do a rough estimate of that voltage, and let's say we get, this amp's going to be cathode biased, by the way, it won't be fixed biased, it's low wattage amp. So let's say, just for rough sake, we're left with 280 volts when the tubes are drawing. So if we square that, so in other words we times that, so 280 times 280. Now if we divide that by 5.4, which is the wattage of the tube, we get 14,518. That would be the primary we need of the transformer for these tubes running at those voltages. And I don't have anything in that line, but Hammond do a transformer, and I can't remember the model number, and I'm just going to go off and get the data sheet for that. Right, so I've downloaded this, I've printed out this data sheet, not just downloaded it, and this is the Hammond transformer that we want to use as an output, as the output transformer. It's push pull, and there's quite a few bits of information there. So frequencies and whatever, we don't think we really need a lot of that. We don't need to be doing a lot of that anyway, certainly not at this moment in time. But what we do need to look at is this. So these are the connections for this transformer and the impedances, and I've seen these transformers used before, and it was Stuart from Berkshire Guitar Amp Repairs, Stuart UK Guitar Amp Guy as he's known on YouTube, and he actually fitted one of these for a reverb driving transformer on an amplifier on a video that I watched, although I had actually seen these transformers before when I'd been researching online. Now if you look at this at the top, again let's get the old pointer, we look at the top, you can see we've got 15 ohms, 12 ohms, 8, 6 going down to 1.5. So we're really only interested in 4, 8 or 16, because of the speakers for guitar amps are generally 4, 8 or 16 ohms, 15 ohms near enough. So we have to get that. And what was that primary again that we did? I've forgotten now. I just have to run the video back and have a look, unless it's still on the calculator, and it is, so I'm lucky. 14,518, so something around 14k. So now if we look, let's look down the, ideally we'd want to be 8 ohms, so let's look down the 8 ohms column, and remember that's only a rough guide, we're only estimating that voltage, so we're looking for somewhere, and the nearest we can see on there is 12,800. So between 12 and 17 it's going to be, because of course we could end up, more than likely going to end up with more voltage. And then if we look down this column, we've got 15,500, so we're 1,000 over there. We'd get away with that probably. I tested the transformer and I put 240 volts in, and I got 262 out. Is 366.8, 367 volts. Now again, we expect that to draw down probably 40 volts, 40, 50 volts. So let's just say 40 for the sake of that. So that's, oops, sorry. So let's just say it drops down 40 volts. So that's going to be around about 326. So 326, if we times that by itself, 326, that leaves 106,000. If we divide that by 5.4, now we're up to 19k as a primary there, 19.5k plus on there. So we're going to be somewhere between 17 and 19 more than likely, knowing what we've got that voltage. So let's just have a look now down the 4 ohms column, and this is where it's going to get difficult to match this up. So nothing close there on the 4 ohms column. 8 ohms column 7,600, and nothing particularly close on the 15 ohm there. So we're going to have to make some kind of a compromise there, aren't we? But we still don't know what the voltage is going to be. We will have, with that extra 20 volts we've got on there now that we didn't bargain for, extra 27 volts, we are now going to have to put something in to reduce the HT voltage. I want to use these transformers. They were cheap, and I'll be honest with you, these I paid £20 for one of them and £25 for the other. And this one, I'm not sure if that is a Banbury. The other one is a Banbury transformer. So these are good quality pieces of kit. Now it's 100 milliamps. That's the other thing we've got to watch. But these, we're pretty much well in, and I know people are saying, oh well, that's more for a single-ended amp, and it probably is, but these tubes don't draw a lot of current. So again, if let's say we run these tubes at 300 volts, so 20 milliamps will be 6 watts. So these tubes are going to be running somewhere between 18 and 20 milliamps, depending how we get that voltage. 40 milliamps for both tubes, and then we've got the preamp tube that's drawing current. So we should be well inside with that, well inside that 100 milliamps. The heaters are 1.5 amps. The filaments, or the heaters, whichever you want to call them, they're 300 milliamps each on the PCL83s, and I do believe a 12AX7 is 150 milliamps draw when it's wired as 12.6 volts. Could be wrong on that, I'll have to check, but I think I am. So 750 milliamps. So the filaments are no problem. It's just, this is where we just have to try and match up the voltage from this transformer and get the correct primary and effective load resistance for the tubes. Right, I've stripped all that chassis down, and I've just laid out where I think is the best place for the tube sockets and the transformers should go. So I've got the pointer, I've got the power transformer on this side, because if we look at the front, which is here, and if I just slot the front in, you can see that the power's going to, it's making the camera flash, but you can see the power's going to be on the right side. So makes sense to have the transformer there, doesn't it really? We've got a full bridge rectifier because we've got no center tap on this transformer. And then I've got the 2 boards here. I don't particularly care for these boards, but they're all we're going to get in this amplifier. We just don't have the space, and we will need 2 of them. 1 won't be enough. We still got these fuse holders here. They are a bit of a distance from there, so I may use those, I may not. The output tubes are here, and the 12AX7 preamp tube will be here. We've got this transformer which I'm just using as a substitute at the moment. I would like to get that perpendicular to the power transformer, but I don't really have the room. I suppose I could turn that round like that and have that maybe like that. Let's get my arm out of the way. So that's an option as well. Now I was thinking, first off, when I first laid it out and got that transformer there, and I had got the tube sockets here and here, that was before I put the rectifier in, but then I didn't like that idea because obviously they've already got AC going to the filaments, and I don't want them being close to this where there's more AC, because of course you've got your AC feeds coming out there. So I just thought a good idea is to put them here, keep them away from the AC, and then we've just got the filament wires running up, which is which you've got no choice because you've got to have that. So that, I think, is the most logical way to run this amplifier, to set it out. Now the other thing is that these, and I don't think we looked at that on the, somebody's probably spotted it on the data sheet though already. If we look, and I might not have that sheet, might not have downloaded that sheet, but anyway, the mu on these, on the triodes on these PCL83s are only 17, so they're 12 AU7 territory. So we need to use those two stages first. We can't be running a 12AX7 stage into those, and we can't be using one of those because we're going to have a cathode phase inverter, cathodiene phase inverter, so that's going to be no use on one of those. So we need to go lowest gain into highest gain. So what we're going to do is use these two stages, another stage on this 12AX7, and then we're going to use the other stage as a cathodiene, and I think that'll give us some pretty good gain there. Yeah, so I think that's going to be the best layout. If I put that transformer the way it is now, I think that's going to be definitely the best way. And so got the rectifier there for two boards. The fuses we may use or may not sure yet on those. Might be okay using them where they are. And then these two boards, output tubes and preamp tube, and power transformer, output transformer. Duh. And there we go. That's now took the chassis out and got it off the bench. I really needed to do that to make sure that it would all fit into the chassis. And of course, this chassis, when it's mounted, the tubes will be on their sides, so they'll be sideways out, because the fuses here, that's the bottom of this chassis, so the tubes will be mounted sideways, which is fine. So I think that's where we're going to go with this, and that's looking pretty good. So what do we need now? We need an output transformer, we need some pots for this, and we also need a diagram, don't we? We need to know what we're going to wire into this. We've got these sockets already here, but as you can see, they're a bit gammy, and I'm tempted not to bother with those. I don't think I'm going to bother. I think we're going to have a switch in there, a double pole. I think we'll use that neon light though. That seems okay. I think we'll use that. Yeah, but I'm not sure about these sockets, to be fair. And we're going to leave those switches in. We may use those for an idea, because if we take them out, we're going to have some holes on there, so we might use those. Of course, for the 12AX7 we need a different socket, because we need one with a shield on it, but I just use that for an example. So now it's down to what kind of circuit are we going to put into this. Do we make one up? Do we copy one? So what do you think we should wire into this project? Leave some suggestions in the comments. I'd be most grateful. So I'm going to leave this one here as part one, and you all take care, and I'll see you all in a future video. Bye bye for now.